Hi, welcome to Examhood. Today we want to look at an interesting topic in physics, and that topic is equation of uniformly accelerated motion. You should know that uniformly accelerated motion is a motion of an object with a constant acceleration. So there are some equations that can define that motion, and the following are the equations. The first equation says that V is equals to U plus AT. That's equation 1. The second equation is S is equals to UT plus half AT squared. That is equation 2. V squared is equals to U squared plus 2AS. That is equation 3. So let's define these parameters where U is the initial velocity, V is the final velocity, then A is the acceleration or deceleration or retardation when the acceleration is negative. Then S is equals to the distance. Then T is the time. So these are the parameters that are involved in uniformly accelerated motion. And these are the equations. So we are going to solve some problems that has to do with uniformly accelerated motion. Now, example 1, let's look at this problem. A car traveling at 54 kilometers per hour slows down uniformly to a velocity of 18 kilometers per hour when the brakes were gradually applied. Then the question is, A, what is the retardation of the vehicle? Then B is how long does it take to cover a distance of 50 meters. So this is the problem of the equation. So a car traveling at 54 kilometers per hour slows down uniformly to a velocity of 18 kilometers per hour when the brakes were gradually applied. What is the retardation? Solution. Let's solve this problem now. Solution. So let's look at this problem. A car traveling at 54 kilometers. Remember the initial velocity is 54 kilometers per hour. So it's in kilometers per hour. We need to convert it to meter per second. While the final velocity is 18 kilometers per hour. So the initial velocity, which is U, is equal to 54 kilometers per hour. We need to convert it to meter per second. That would be 54 times 1000 all over 60 times 60. 60 times 60 is we are converting from 1 hour to second. So it will be 54 times 1000 will give us 54,000 all over 60 times 60 will give us 3,600. So by the time you divide this by this, we are going to have 54,000 divided by 3,600. We are going to have 15 meters per second. 15 meters per second. So that's your initial velocity in meter per second. So the final velocity V, which is 18. Remember the final velocity is D. From this 54 to 18 kilometer per hour. Let's look at 18 kilometer per hour. Convert it to meter per second. That will be the same formula or the same procedure. 18 times 1000 all over 60 times 60. That will be 18,000 divided by 3,600. By the time you divide 18,000 by 3,600, you are going to have what? 5 meter per second. If you divide 18,000 by this, you're going to have 5 meter per second. So that's your initial velocity. I remember the distance in that journey is 50 meter. The distance is 50 meters. So the first question says we should calculate the deceleration. Remember, deceleration is acceleration with a negative value. So we're going to use this first equation of motion to find the acceleration, which is v squared. Which is v is equals to u plus at. So we're going to bring in our values here. V is 5 meter per second. U is 15 plus our A. The deceleration is what we are looking for. Is A. Our time is the time given. Sorry, for us to find the deceleration, we are rather using this because the last equation has a final velocity, the initial velocity, and the what? The distance. So we are not using this first equation. We are using the this last equation, which is v squared is equals to u squared plus 2as. Our final velocity is 5 squared is equals to our initial velocity is 15 squared plus 2. Our acceleration is what we are looking for, which is deceleration times the distance is 50 meter. 50 meters. So we have 5 squared is 25 times 5 times 5, which is 25, equals to 15 squared is 15 squared is what? 225 plus 2 times A is 2A. 2A times 50 will give you 100A. So we collect items. These 225 come to the left hand side. It will change to minus 225 minus 225 is equals to 100A. So 25 minus 225 will give us minus 200. Minus 200 is equals to 100A. So for you to get your A, now A is equals to minus 200 all over 100. And minus 2 divided by 1 will give you minus 2. So the deceleration is minus 2 meter per second square. Remember, the unit of acceleration is meter per second square. So the acceleration, which is deceleration in this case, will be minus 2 meter per second square. That's your answer to the first question. So the second one is we are asked to find how long does it take to cover a distance of 50 meters. So for us to find the time, how long is the time? We are asked to find the time. So we're looking at, we are using this first equation, which is V is equals to U plus AT, because we have final velocity, we have initial velocity, we have the acceleration or deceleration. So we are going to use this equation. Our final velocity, remember, is 5. The initial velocity is 15 plus the deceleration is minus 2 times t. We are looking for the t. 5 is equals to 15 plus minus is minus 2t minus what? 2t. So we're going to have 5 is equals to, from here we're going to collect like terms, carry 15 to this side, becomes 5 minus what? 5 minus 15 is equals to minus 2t. 5 minus 15 will give you what? Minus 10 is equals to minus 2t. Divide both sides by what? Minus 2t. You're going to have t is equals to minus 10 all over minus 2. Minus cancel, minus 10 divided by 2 will give you what? 5. So your time is 5, or the time taken for the vehicle to cover 50 meters is 5 seconds. So these are your answers. 5, the deceleration is minus 2 meters per second square, while the time is 5 seconds. These are the answers to this the first problem. Thank you.